Okay, sorry about that, guys. Okay. Welcome to another session. Today we'll be doing trigonometric substitution. I hope you guys have tried to check it out before you got to this session. I hope you got the previous videos as I uploaded them on our YouTube channel. Again, I'd like to but it's fine. Let us just go through the session, and then the rest we can discuss it after the session. Okay. So today we'll be doing trigonometric substitution. As I said, that's another form of integration technique. It's an integration technique which is very nice. It usually deals with something that we call the inverse substitution. Okay, it's something that we call the inverse substitution. You know that when we're given something like the integral of maybe let's say x all over, let's say 2x all over x squared dx. Okay, let's just take a square root here. We know that direct substitution, we're going to say let u equals to x squared, and then du is equals to 2x dx, which is the top part. But in this particular case, we're going to do the inverse, or the inverse, not the reverse, the inverse substitution. Okay, today we'll be doing the inverse substitution. Now, in this particular case, this thing is liked most of the time by the functions that we know very well. I know we did them last year. Those functions, we call them functions which are cluster. We call them functions like f, g. Okay, so that's when this simply means that you have got a function inside a function. Okay, so once you've got a function inside a function, we can denote this. Okay, let me put x here. We can denote this as f at g at x. Then we have clustered this function when we have put another function inside another function. Okay, so in this particular case, we knew that the chain rule has to be used once we have functions which are inside another function. So the derivative of this whole thing, ddx of f fg is equals to f prime of g at x multiplied by g prime at x. Okay, so in this particular case, in this particular integration technique, we'll be using the integration of such functions. Okay, we'll be using the integration of such functions. What I mean is, when you integrate f at x dx, it will be the same thing as integrating f at g at t. Let me use t, g prime at t dt. Okay, but it's not something which I wanted to dwell too much on. I wanted us to understand this trigonometric substitution. Okay, this is just background information about where we have got a function inside a function. Okay. But today I just want us to speak most about rules that govern this technique. Okay, so the most important thing, rule number one, or the most, it's not like the most important thing, but it's something which you really need to understand for you to be able to master this technique. Number one is that we have got something that we that is denoted by, okay, so I thought somebody had a question. All right, so this is what happens, guys. Yeah? We have got an expression. Okay, this expression, this expression is given by a squared minus x squared. Okay, and this expression has got a domain. Okay, it has a domain, but let me not go into the domain at first. Let me try and explain what this expression means in terms of substitution, and then we're going to have its domain. When we are saying substitution, we are saying that we are going to always let x be equals to a sine of theta, and then we're gonna be having that thing in this domain. Okay, I think it's included. Okay, so this is what happens. We do have an expression which we are always going to use a certain substitution rule when we see that particular expression. And that expression is always a perfect square of any number, provided that, let me write this one, provided that our value of A is always greater. Because now if our value of A, well, let me just say the value of, let me just leave. The value of A should always be greater than 0, okay? It's very important for the value of A to be greater. Because let us suppose now that we have got negative A squared, okay? When you've got negative A squared, this whole square root will not hold, or it will not give us a solution. Then we are going to say that this thing is an error, or it's undefined. But in this particular case, just make sure that your value of A is always greater than 0, okay? It's always greater than 0. We don't want it to be 0. We didn't say greater or equal to, we said 0. It always has to be greater than 0, okay? So the identity that is going forward with this, it's going to be given by the Pythagorean identity, which we know very well. I'm very happy that you guys, you know some of these things. So it will help us to even solve the problems very quickly. Yeah? So what's going to happen is, after all of these things, you need to understand that you can denote, or however, show a geographical representation of the whole thing. Okay, the geographical representation of this is given by so we're gonna have A squared minus X squared here. Here we've got X and A. So all of this thing comes from us understanding the Pythagoras theorem, which says that X squared plus Y squared is always equals to R squared. In this case, our R squared is A squared, okay? And then these ones, they stay the way they are. And as you can see that we just took the X this side, we had Y squared is equals to A squared minus X squared, where we had our Y as the square root of A squared minus X squared, okay? So you don't need to cram all of these things. No, you don't need to do it. You must just understand the fact that this particular case, you have got a value of Y. The value of Y is defined by A squared minus X squared. And in the case where we are given the value of X is equals to the square root of A squared minus Y squared, you see that in either way, it gives us more like the same solution, but it's not really the same solution. Yeah, it changes somehow. So it's very safe for you to play. But in this particular case, the value of A should always be 10. Okay. So the next thing that I want to tell you is that the relationship of this triangle geographical representation should always, you should always make sure that you put this relationship such that you can be able to produce, or I don't know which term to use, but to make sure that you do have the value of X over A over whatever. Like, you should make sure that if you want to define tan of theta using this triangle, you can define that particular trigonometric function. Okay. In this particular case, let's say I want to find tan theta using this. It's possible because I know that a right angled triangle, I must show it. It's a right angled triangle will always be able to give us those values of trigonometric functions. Okay. But I didn't want to speak much about this thing. Okay. I don't want to dwell too much. Okay. Oh, so we do have something like that. What else can I say? What else can I say? Oh, as you can see, we said X is equals to that. Okay. So what is going to be our dx? Our dx is just the derivative of this. Okay. But look at our derivative. What is our derivative with respect to? It is with respect to theta, because theta is our unknown as well. So therefore, we're going to have a cos of theta, which we usually write it like this: a cos of theta, t theta. Okay, so this is what we usually write. But this is just one of them, okay, guys? This is just one of them. So let me just about this. Let me just write out the other two. And then we don't need to actually like go through it that much, because like my duty as your tutor is to make sure that we know how to solve most of the problems, or help you solve the problems that you have about a particular topic. Okay, so let's look at number 2, which is given by a squared plus x squared. Even if you can get x squared plus a squared, it's still what the same. Okay, and then this one defines a is equals x is equals to a tan of theta. Okay, x is equals to a tan of theta. Then it is defined on the same domain as this one, theta at this time. So what happens is the identity that we're going to use for this one is 1 plus tan squared theta is equals to sec squared theta. Okay, so this is what we are going to use. Okay, and then our geometrical representation of that is the question that you guys might have at the moment is, how do I know that this should come in, that should come in? Okay, it's simple. It's actually simple, because if we can check, let us rewrite this. Let us rewrite this in terms of what do you call this? Quotient. Okay, so what I mean is we're going to have our sine of theta being equals to x over a. What do you know about sine? Sine is always the opposite of hypotenuse. Opposite of hypotenuse, where this is our opposite and this is our hypotenuse. You see that, guys? Meaning that for me to find the that side, I'll always have to use what? The Pythagoras theorem. Okay, and you remember I proved it here. That was the Pythagorean theorem to show that this adjacent side is given by a squared minus x. Okay, so the next one is this one. Okay, so this one we know is tan, and tan is given by what? Opposite over adjacent, and we know that the opposite side is always the opposite side is always opposite to the given angle, and then the adjacent side is the closest side to the given angle. So the opposite side is this one in this case, and the adjacent side is this one, then which means this becomes our hypotenuse. Okay, so you don't need to cram this, guys. Please make sure that you understand how to do these things. Okay, and then what else do I need to do? Okay, we know that if we're given this, we can find x and stuff like that. So let me just skip to number 3. Okay, so number 3, it's very tricky. Okay, because people, they think this and that is the same thing. This and that will never be, unless we multiply this or that with a negative. If not, then this thing does not. Okay, so we can't just assume that that is true. Okay, and then this one represents a sec of theta. Okay, and then this one has got a slightly different domain, which is given by a, okay, so I've got such a domain. Okay, but it's not only defined here. Oh, I think it's also defined in I think it's also defined in I think it's 3 pi by 2. Yeah, 3 pi by 2. Yeah, sure. Between 180 degrees and 270. Okay, it's always defined. It's defined between 0 and 90, 180 and 270, so on and so on. Okay, as much as this one is defined between negative 90, you see, and this one is also defined between negative. Okay, but we don't need to. I was gonna sketch and make this thing very interesting, but we don't need to. Guys, I just want to keep this as simple as possible. Okay, I just want to keep this as simple as possible. So what we are going to use for this one is going to be sec squared theta minus 1 is equals to tan squared theta. It's just us taking this to the other side, okay? And then now we're going to use the same idea, but now we know that sec is just 1 over cos, okay? Just 1 over cos, meaning that if cos of theta is given by x over r, then sec of theta is given by r over x, because this is just a reciprocal of this. And the reciprocal is just a multiplicative inverse. Multiplicative inverse always gives you 1, okay? Always gives you 1. So what the reason why I was giving you this was to show you that since we know that our sec of theta in this case is equal to x over a, this becomes our hypotenuse, okay? This becomes our hypotenuse, this becomes our adjacent side, and then automatically this becomes our opposite side, given that this is theta. Okay, so guys, this is just us going through some theory on this particular technique. So I don't want us to do much about that one. Let me just give you a number of examples. Do you have any questions, guys? I know I spoke a lot. Speaking. Please do you have any questions? Do we have any questions at all, or should I just continue? You guys are fine. Okay. It's fine. Let me try and see if I can. Okay, so you guys, you must be able to do as much questions as possible in the textbook. That textbook, the prescribed textbook is there, and it's very helpful. Like, it helped me to go through this module fast. Okay. So let us try some examples. Let me say I give you an integral of square root of 9 minus x squared all over x squared dx. Okay, so we're given something like this, guys. First thing first, we can determine if whether it follows this a squared minus x squared, this a squared plus x squared, or this x squared minus a squared, which this one is related to a x is equal to a sine of theta, x is equal to a tan of theta, and then x is equal to a sec of theta. Okay, I want you to look at the relationship between these three trigonometric functions. Just take note that these are the true trigonometrical functions, and then we have got their co-functions, which is called cosines, cotangent, and cosecant. We are only dealing with the true trigonometric functions. Okay, take note that it's also important, but it's not something you should say that you need to remember. It's just me trying to make this fun. Sometimes I make it like it's very advanced. Okay, so okay, let's do what we know. Okay, let's let x be equals to 3 sine of theta. Okay, what I know is that this represents a squared. This represents a squared minus x squared, which means we are using the first condition. Okay, so what's going to happen is that let me this dx is equals to 3 cos of theta. Okay, so what's going to happen from here is I'm going to define this with respect to x. Okay, what I mean is I'm going to have the square root of 9 minus x squared being equals to the square root of 9 minus 3 sine of theta, and I square everything, which is equals to the square root of 9 minus, what is 3 squared? It's 9. And then I have sine squared of theta. Then this will be equals to, the common factor in this case is just 9. Then I'm left with 1 minus sine squared of theta, which this is a trigonometric identity. Oh, sorry about that. I just got the notification. Sorry about that. This is a trigonometric identity which tells us that this is equals to cos squared of theta. And if this is equals to cos squared of theta, it tells us that we've got the square root of 9 cos squared of theta. And these are perfect squares, okay? These are perfect squares. What is the square root of 9? It's just 3. What is the square root of cos squared? It's just cos of theta. So wherever I see this root of 9 minus x squared, I'm always going to substitute this, okay? So what more do I need to define here? Okay, we have got our x, we've got our square root of 9 dead, we've got our dx, so we don't need anything else. We can just go straight and solve the problem. Okay, so we've got the square root of 9 minus x squared all over x squared x. Okay, so what you're going to have is the integral, and then for this, I'm just gonna write 3 cos theta, and then for x squared, I'm just gonna write this 3 sine theta squared. For dx, we've got 3 cos theta, and then for theta. Okay, there's nothing else that we need to do here. So what is gonna happen is gonna have this as 9 cos squared theta all over 3 squared is 9, sine squared is sine squared d. Okay, and as you can see, these ones are just gonna give us 1. Okay, and then the next part it's a part which we like cot squared theta. Okay, and the nice thing about this is that we can define cot squared, right? We can define cot squared as cosec squared theta minus 1 d theta. Okay, the question might be, how do I know that this is true? Okay, I usually do this in my head, r squared. Okay, and then I ask myself, what is cot with respect to x and y? Okay, because we know that cot is the co-function of a tangent function, meaning that our tan of theta is given by opposite, which is y, all over adjacent. Then our cot of theta will be equal to x over y, meaning that in this particular case, I have to divide each and every term such that I have x over y. So I must divide each and every term by y squared, okay? Y squared, okay? And in this particular case, as you can see, we have got a cosecant and we've got a secant. The cosecant is just the co-function of the secant function, and the secant function is just 1 over cos. So 1 over cos is simply r over x. Okay, r over x. Yeah, it's r over x. So what happens is, in this case, we're going to only look at the fact that the solution that we're going to have here is going to be with respect to cosec. Okay, and the only way to have cosec is if you've got r over y, because cosec is with respect to sine. So x over y is cot. It's cot squared theta plus 1 is equals to cosec squared theta. Okay, cosec squared theta, because this is just the reciprocal of sine, and then sec is the reciprocal of cos. Okay, so this is what happens. I've got cot squared of theta is equals to cosec squared of theta minus 1, and this can be written instead of writing cot squared of theta. Okay, that's why I wrote it here. I didn't think I would need to explain that, but I feel like for us to understand even better, it's always better for me to give you some few tips to help you be able to, yeah. Okay, so the next part is we know what is the derivative of cot. I think the derivative of cot is negative cosec squared. It means that the integral of cosec squared is negative cot, okay, of theta, and then the integral of 1 over of 1 d beta is just beta, okay, and then you're just going to have a constant. The question is, are we done? Guys, are we done? Do you think we are done? Guys, out of, let me, oh, somebody said, please repeat the last part. Which one is the last part? Which one is the last part? Please repeat the last part. Which one is the last part? Yes, hope. Hope. Okay, so people are saying there are questions in the comment section. Oh, the last part was the third rule. What do you mean by third rule? Third rule. Oh, this one. Is that what you want? Oh, so what do you need? What do you need an explanation? What do you need to be explained about this rule specifically? Oh, that's not you. Sorry. It's fine. It's fine. Since that person doesn't want to speak, I guess just continue. Oh, guys, do you realize something? I showed you when I was defining. I showed you that sometimes it is important for you to draw those. I didn't say sometimes. Actually, it's always needed to draw those right angle triangles. Okay. Now look at this. At this particular case, we are going to ask ourselves, what is cot of theta? Okay. What is cot of theta? We don't know what is cot of theta because we don't know the right triangle that we have to have there. So me doing all of this thing was to just show you that from here we're going to be stuck because there's nothing else that you can do. You can't define cot of theta because we do not have a right angled triangle such that our trigonometric function is defined. So in this case, I'm going to draw a small diagram here at the corner, smaller diagram. It's theta, and it has to be a right angled triangle. Okay. So what happens is, we know for sine that sine is given as opposite of hypotenuse. Okay. Opposite is given as x, and then hypotenuse is given as 3, which means that this is given as 9 minus x. Okay. 9 minus x squared. So this is what is going to give us our solution. Okay. So we know by definition that cot of theta is just a cotangent. Okay. It's a cotangent. It's a cofunction of tan. So what happens is that you are going to have, because we know that tan is y over x, this one is just going to be x over y. Okay. It's always going to be x over 1. And in this case, we know that our x is adjacent and this one is our opposite side. So this is our adjacent side because it's closer to the given angle, and then you've got the opposite side. So the opposite side is it's x, and then our adjacent side is 9 minus x squared. Okay, so you must always I think it's too bright. Let me try to do this. Okay, so as you can see here, we've got this part where we are defining our chord with respect to x and y, which is the opposite side. I mean the sides of a right angle triangle. Let me just call it like that. So our x in this particular case is the adjacent side, which is 9 minus x squared all over our opposite side, which is just x. Okay, so now we have defined chord, and then the next thing is coming back to this left part. We've got x is equals to 3 sine of theta. Then we can find our theta here, or we can find our theta here. But for purposes of making this to be a simple or explainable concept, we're just going to use this one. So we're going to have x over 3 is equals to sine of theta. Then we take arc sine on both sides. Then you have theta is arc sine x over 3. Okay, so this simply means that the solution, the final answer for this thing, which we have the square root of 9 minus x squared all over x squared dx, will be equals to chord, which is negative this 9 minus x squared all over x, and then you're gonna have minus, what is theta? Theta is arc sine of x over 3 plus this becomes our final answer. Okay, I know it's tedious, it's long, it's boring, but it's a great way for us to be able to solve some problems, because some problems are not easily substituted or anything like that. Okay, so guys, let us make this thing to be very interesting. Let me give you a problem which you are going to do. Okay, which you are going to do. I'll just give you 5 minutes to complete it. I know you can do it. Trust me. In you I trust. I know. Okay, so this is the problem that I want you to do. I hope that you are getting this concept that I just gave. Okay, so let me give you a problem. So let me rub here. I know some people are still teaching. So your problem that I'm gonna give you is find the integral of x all over the square root of x squared minus 7x. So I gave you a little bit of a problem. I'll give you 5 minutes to complete this problem. Okay. Do you guys think this problem is going to give you a hard time, or feel like maybe? Okay, let me not ask a lot of questions. Let's just, yeah, let me just leave it. Okay. So I'm setting a timer to exactly okay, so I've got a stopwatch here, which is starting now. I'm gonna give you exactly 5 minutes. Okay. Trust that you guys will be able to solve it. It's one problem. It is x squared minus 7, square root of x squared. One minute gone. Still got 4 minutes. I know you guys are solving this one. Finding it very easy. Finding it very trust. Okay, 2 minutes has elapsed. But 3 minutes remaining. But if you have solved it, you can just give me the solution that you got. Yeah, and then I will give you the solution that I got. Okay. So if I'm not solving, let me solve this. 3 minutes has elapsed. So we have an answer. We have an answer. Okay. So 4 minutes has elapsed. We've got less than a minute left. Okay. Less than a minute. 30 seconds left. Like 5 minutes. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So we stopped exactly at 5 minutes. Okay. So what happens is the reason I want you to do this problem. Oh, actually, what is the solution? What is the solution that you found? Right? Before we can continue, say what is the solution that you found? And nice solution. Anybody who wants to share the solution that anybody? So that 5 minutes, you guys were okay. Oh, so you couldn't get it. Okay. Okay. You know what I'll do? I'll show you that this was just a trick question. Okay. I was just tricking you guys. to doing this. The thing is, I want to show you something. You do not need to forget anything else that you have done so far because of a concept that you are doing in that particular. Some of the questions that you're going to get in that particular concept are just going to be the same problems that you're going to get on a different concept, okay? Because it turns out that this question in your textbook, it's regarded to be a hard question, okay? Because like I'm taking your textbook here, it's this question, it's question number 17, and it's given this red color here. Né? This red color means that it's a hard question, it's a challenging question, but it is not really that challenging, okay? It's a trick question, okay? What I mean is literally this is a trick question because the solution that you are supposed to find is just this one. We just use U substitution. You understand? We just use U substitution, and we did U substitution when we were doing our introduction to antiderivatives and integrals. Okay, so the solution is this, which comes from the substitution. Okay, so I was just trying to show you that this thing comes from trigonometric substitution and everything, but it doesn't actually mean that everything that you're doing there you should use trigonometric substitution. Okay, it's just a trick question, guys. Please pay attention to the questions that you are being asked. Okay, please pay attention. They like tricking us like this. Okay, so let me take another example. Let me take another example. Let me take let's say, okay, let me take this one. Okay, take this one. So I've got 3 minus 2x minus x squared dx. Okay, so the question just says evaluate. Now the question is, how am I going to evaluate such a thing? I've got a huge beast thing here, which I don't know what's going on with it and stuff like that. Okay, so what I will do is I'll be integrating 2 rules. Okay, I'll be integrating 2 rules. The approach I'm going to take is, now look at this bottom part. Okay, let's deal with the bottom part. Let me use it. I've got 3 minus 2x minus x. Okay, we can't simplify this any further. Okay. Oh, I don't need to simplify it any further. I just need it to satisfy one of these 3 conditions. Okay, let me do this. Let me have 3 minus 2x minus x squared, and then let me have half of the coefficient of x, which is 1, and 1 squared is just 1, and subtract that 1. And you know what we call this this rule? Guys, do you know what we call this rule? Do you know what we call this rule? Okay. So guys, do you know this rule that we use where I'm going to add 1 and subtract 1? It's more like I'm adding 0. I think you did this rule in grade 11. Any of you know this rule? Okay, it's called completing the square. Okay, this thing makes life very easy. Okay, complete the square. So what's going to happen is I'm going to take this one, 3 plus 1 minus 1 minus 2x minus x squared. Okay, so I'm going to have 3 plus 1, which is 4, subtract, then have 1 plus, okay, rather than that, let me just write it in there, formal 2x plus 1. Okay, so this is factorizable, so this can be written as 4 minus 1 x plus 1 squared. Okay. So in this particular case, we do have this now. Okay, we do have this. But I want to make this into very, I don't want to say interesting, but let's let u be equals to x plus 1. It means that du is equals to dx. And let us at the same time define x with respect to u, meaning I'm just going to take this one this side, comes u minus. Okay, you're going to see why I'm doing all of these things now, because I feel like some of these things, okay, let me not give it out. Okay, now we have got a new definition of this. This x all over 3 minus 2x minus x squared dx is now defined as x all over the square root of 4 minus x plus 1 squared. Okay, so this is what I get now, you see. So this satisfies which condition here? It satisfies the condition of sign, which is the first condition. Okay, so 4 minus this thing is more of us saying that let us let u be equals to that, meaning that we are going to change this because our x is given by that u minus 1. So we're going to have this as 4 minus u squared. And 4 minus u squared looks the same as, oh, it looks like, yeah, looks like the sign on. You see that, guys? U in this particular case just replaces the x because both u and x are variables. We do not know the values of u and x. This is 4, guys. Looks like u as well. Okay. Do you understand the concept here, guys? Okay. If you don't understand, please do that. Okay. Please do let me know. Okay. So this is just a new definition. I haven't solved the problem as yet. Okay. Now we're going to come and do the part which we all love. So we're gonna let u be equals to, in this case, I said to you, u replaces x. Okay. Usually we're going to say let x be equals to something. In this case, we're going to say let u be equals to 2, which is the value of a. Okay. And then you're gonna have sine of theta. Okay. And then thus our du is equals to 2 cosine of theta. Guys, I need you to be with me. Okay. I need you to be with me. Are you all guys with me? If you are not with me, please get that I can be able to assist. Okay. So let us define this bottom part. Okay. I'm defining the bottom part. The bottom part is given by 4 minus u squared, but our u is given by that. Thus, we're going to have the square root of 4 minus, what is u? Is 2 sine of theta squared. Okay. So this becomes the square root of 4 minus 4 sine squared of theta. And then this will be equals to the square root of, so we're going to have 4, 1 minus sine squared of theta. My pens, come on, man. Okay, guys, I'm running out of pens here. Right. Okay. So this is what happens now. We know what this represents, okay? We know what is this. This can be written as cos squared of theta, okay? This can be written as cos squared of theta, and the square root of 4 is just 2. So my final answer becomes this. Okay. So now, as I'm solving this, now I'm solving. Now I'm solving because we have got almost everything. And I'm saying almost everything because I need to draw this triangle of mine. Let me draw it. Or don't see it. Let me have my triangle over here. I hope you can see it. Theta, 90 degrees. Okay. Now, we know for sine. Sine is defined by what? By opposite over hypotenuse. Opposite is given by y, then hypotenuse is given by r. Okay. So, which means here lies u, and here lies 2, Here lies the square root of 4 minus u squared, which is the okay. Now we are going to the part where we are solving. Okay, I want to take this thing away for a little bit. Our triangle will come back to that one. Let us solve the problem. So this is exactly the same as 3 minus 2x minus x squared. This is exactly the same as where is it? This one. So I'm gonna write this as, everywhere where I see u, I'm gonna substitute this. Okay, so I'm gonna have 2 sine of theta minus 1 all over. Now this is given by 2 cos theta, 2 cos theta. Okay, and then what is our, oh, I forgot the x. Here I should write this thing with respect to u. So therefore I should introduce. Now in this case, guys, I want you to look at something. If ever I'm going to introduce this with respect to u, I must introduce 2 cos of theta as well. Okay, I must introduce 2 cos of theta. So therefore this can be rewritten as, for me to find, no, let me just write it. I'll tell you why I'm doing that. Okay, I'll tell you why, because this thing is written as well. I should not change it as yet. I'll tell you why. Okay, now this is the part where everything changes. This is the part where everything changes, because now if you can remember from here, this was just a definition of u is x. So I'm treating u as x. That's why I'm not changing it here. As much as our previous example, we did not say, because x, we have to divide. No, we can't do that. Okay, we treat u as x. That's why I'm leaving it. I nearly made a mistake of using u as the substitution. Okay, it is the substitution, but we're treating it as x. Okay, it's just a special case. So here we're gonna have 2 cos of theta d theta, which is d is equal to x. Okay, and as you can see, the 2 and the 2 goes, cos and cos goes, then you are left with the integral of 2 sine of theta minus 1 d theta. Okay, are we fine with the ideas, guys? Okay, if you're not fine, guys, as I always say, please do that such that we can deal with this. So here we're gonna have 2 integral sine of theta d theta minus the integral d theta is equals to, this becomes 2 negative cos theta, because the integral sine is negative cos, minus theta plus c. And then we would be overexcited saying that we have solved the problem, and we haven't solved the problem, right? Because we know that we can define cos theta. Okay, but before we go on and do many things, let us just define theta first using u. Okay, because that's the only relationship we have between u and theta. Okay, so this becomes, sine of theta becomes u over 2, meaning that theta is equals to arc sine u over 2. Okay, and then we are going to find theta with respect to u from our triangle. I mean cos of theta. Okay, and now, okay, let me just define it here. Cos of theta with respect to this, it becomes x over r. What is our x? Our x is, what's this one? Is given as the square root of 4 minus u squared all over r, which is just 2. Okay, so guys, I'm making it long because I want you to understand. Okay, I'm just making it long. Otherwise I was gonna skip some steps and stuff like that. Okay, I was gonna skip a lot of steps here. But for me to make sure that you guys understand, I want to keep it as long as possible. Okay, so now we're gonna have this negative 2 cos of theta is given by the whole thing that we defined there at the top. Unfortunately, we can't see it because this thing, so we're just gonna come and substitute it here. That thing is given as the square root of 4 minus u squared all over 2. Okay, and then you're gonna have minus arc sine u over 2 plus c. Okay, so we have that. We have this. We are happy. Okay, but we are not done. You see that these two, they will give us 1. Don't cancel. I don't like this idea of people saying this is cancel. Give us 1. So now, this is the part that becomes interesting. Our initial problem was with respect to x, so which means our final answer should be with respect to x. And if you can remember clearly, 4 minus u is this, okay, with respect to x, since we said that our u should be equal to x plus 1. It means that for me to bring this thing back, I can simply say 4 minus u is the same thing as this. So therefore, let me just write it as 3 minus 2x minus x squared. Okay. Oh, sorry about that. 3 minus 2x minus x squared. Okay. And then I'm going to say minus arc sine. And what is our u? Our u is given as x plus 1 over 2. As it comes. Okay. Do you have any questions? Guys, I'm not expecting you to master these things in like in one session, say that you guys mastered the whole. All I need from you guys is just for you to be able to participate. If you participate, you're giving me the thing. You're showing me that you really want to know these things. Okay. And do you have any questions? I'm asking again before I show you something. Okay, I'll take that as no. So you see, you guys, you didn't show me that this narrative. See, okay. But such questions are easy. Okay, such questions are easy. Let me see. Let me take a red colored question. Number 7. So these questions are coming from a textbook, guys. Okay, they're coming from a textbook, and this is number 7. It has that red color that I was telling you about. Okay, so I'm gonna do number 7 as an example. As an example, I love these red colored ones because they are regarded the out of the box questions. I love such questions. Okay, so I'll remove the top part here because some of you are still writing. This part here. Love such questions. Love. Okay, so this video, I'm gonna upload it just after this session. Just after this session. Okay, so I need to rub everything out such that I can be able to use this. So guys, are you sure you don't have any questions, guys? Or you are still trying to process the whole thing? If you're still trying to process the whole thing, it's still okay. You don't need to have questions if you want questions. And also, if you are still processing, take all the time. But if you've got any questions, ask at any given time, okay? At any given time. Please do check these questions as well, okay? Just because I solved it for you doesn't mean you have understood how it's solved. It can come in a test, assignment, in an exam, and now you are there like, I saw this thing on the video, but I can't solve it, okay? So number 7 in our textbook goes in a form of, say we're going from 0 to A, and we have x, and we have a squared plus x squared to the power 3 over 2. Okay, so they are saying the condition that our a should be greater. Wow, wow, I love such questions. I'm getting excited already. Getting excited. Okay. Let me be sure No, got the right question. Okay. So from here, yeah, the most important thing is understanding trigonometry. Okay. Understanding trigonometry. No, exponents. If I'm given x 3 over 2, this simply means that I've got the square root of x and this thing is cubed. This is what it means. These two are exactly the same. Okay, these two are exactly the same. So I'm gonna use the same idea over here. Okay, but before, I want you guys to tell me, does it satisfy condition 1, condition 2, or condition 3? This thing, does it satisfy condition 1, condition 2? Yes, it satisfies condition 2. Now, thank you for answering Moape. Right. Now, let make sure it's well shaped. Let x be equals to a tan of theta. Okay. A is a, right? In this case, a is a. It's just, and then our dx is equals to a sec squared for light. All right. The other thing that we need to do as well is have a little geographical representation. Graphical representation. Okay, so what do we know about tan? Tan is opposite over adjacent. So opposite is x, adjacent is a, and this just becomes our square root of a squared plus x. Okay, a squared plus x. I know my handwriting is bad there. I don't know what was. Okay, now we need to define a squared plus x squared to the power over 2, to the exponent 0 over 2. This can be rewritten as the square root of a squared plus x squared to the exponent 3. Okay. And we said that our x is equals to a tan beta. Then we're going to have this as the square root of a squared plus a squared tan squared. Let's keep the step. Must be our the step of showing that this is substitution. Okay. This is substitution. What is common? Is a squared. Okay. So we've got a squared 1 minus tan squared beta. Okay. And this is a trigonometric identity. So you're going to have a square root of 1 minus tan. Oh, it's plus, sorry, it's plus. I don't know where it is. 1 plus tan is sec squared beta. Okay, it's sec squared beta. So if it's like that, oh, still got this. If it is this, then it becomes a sec beta, and it's still cube, which is a cube sec cube. Okay. Okay. Such nice questions. Beautiful. Beautiful question indeed. Right. So this becomes from 0 to a. This becomes let's substitute. Direct substitution. Dx is this. So I'm gonna have a sec squared beta d beta all over. Now the whole thing is just defined by the a cubed sec cubed beta. Right. So usually how I write this is I don't like to write. Okay. And as you can see, this goes, it's left with 2. The whole thing, this one goes, we're left with 1. Then this becomes 0, a 1 over a sec beta. Okay. Okay. No, it's actually a squared sec beta. A squared sec. Because this is cubed and this was just a, so it becomes this. And then we still have that. I hope you guys can follow, okay? So I've got 1 over a squared, and then we have the integral of 0 to a of 1 over sec beta beta. Okay, so we do have this which exists. So let me just do this. So since we are saying that sec is the multiplicative inverse of cos, 1 over sec must be equals to cos. Okay, should I prove it? Maybe. If I've got 1 over sec of theta, and we know that sec of theta is given by 1 over cos of theta. This means we've got 1 over 1 cos of theta, which this is 1 divided by 1 over cos of theta, which is 1 multiplied by cos of theta, which is just cos of theta. So rather than writing this whole thing, I can just say now this is equals to 0 to a cos of theta. Okay. Okay. So this becomes that thing that gives me a derivative, which is cos of theta sine. From 0 to a, I see my mistake here. 1 over a squared. 1 over this becomes sine of theta from 0 to. Okay. But in this case, I don't want to. I don't want to complicate this. Okay. Let us go back to our triangle. What is sine of theta from this triangle? Sine of theta, we know it's given by y over r. Okay. What is our value of y in this case? It's x. What is the value of r? It's just a. Okay. Am I correct, guys? No. It's actually the square root. It's actually a squared plus a squared. This is r, which is hypotenuse. Okay. So what I'm going to do is I'm seeing a relationship. This relationship is not between eta and a, it's between r and a. Okay, it's between r and a. So I can just write this as squared. And then this is x over the square root of a squared plus x squared from 0 to a. Okay, because we are substituting directly from to x, right? So the relationship of this a is at x, exactly at x. Okay, exactly at x, not at eta. That's why I'm saying I'm skipping this part of writing our a here. I can't write it here because it is not a relationship with eta, but it is a relationship with x. Okay, the relationship is with x, strictly x. Okay, there's no mistake of having another being. So this becomes a, because we're substituting a wherever we see x. So you're gonna have a squared plus a squared, because this is x squared. And then the values of 0 is just going to be 0 over that, which is just 0. So I'm gonna write that 1 over a squared. Then I'm gonna have a square root of 2a squared, because it's this plus that. And then have this as 1 over a squared, and have this as a over the square root of 2a, this and that goes to town. So we have 1 over square root of 2a squared. Okay. I love such questions. Hey. I love such questions. Okay, do you have any questions? Do you have any questions regarding to what we do you feel like you need to do more, or do you feel like we're doing too much? Isn't x equals to a tan 0? No, it's not tan 0, it's tan beta. remember that our A cannot be equal to 0. Our A cannot be equal to 0. Our A is strictly greater than 0. Okay. There isn't a theta sign. There is a theta sign. There is theta. There is theta. There is theta. Maybe it's not clear. I don't know. My handwriting is terrible, guys. I thought you know. Oh, oh, oh. Oh, I get where the question is from. Oh, yes. Oh, yes. Oh, yes. Now, in this case, what makes this problem to be a different problem is we are given the limits of integration. Okay, so we can just substitute direct to x, not bring it back to theta and a. Because if we wanted to write it in terms of theta and a, we would have just did it here. You understand? But in this particular case, we can't do that because our a only relates to x, doesn't relate to theta. Ne? That, like, you understand what I'm trying to explain to you. Like our a relates exactly to x, not to any other variable. Actually, there's no any other variable. The only variable we have is x. It's just that we introduce theta as the new variable because we are trying to simplify the integration process of this particular question. Okay, so in this case, our relation is between x and a, and therefore we do not need to change our x with respect to a times. Understand? Please give me a thumbs up if you understand, okay? And if you don't, please give me a thumbs up. Okay, you get it. Thank you very much. Thank you. The reason is because we have given a bit of integration. Okay, that's the reason. Okay, so guys, do you feel tired? Do you feel like we should have another question? Maybe. Yeah, please let me know, guys. You still got me. You still got me. I can take another question from textbooks. Okay, let me take a screenshot of those who attended. And remember, guys, I'm going to send you this link, which you need to show that I was helping. Okay, to show that I was helping. Okay, guys, do you feel tired? Do you feel like we should continue? Do you feel out of touch? Do you feel like you need to practice maybe? Because I can do another question if that's what you should. I do another question? Should I? Come on, guys. You can't give me the silent. Is there another one I can do similar to this? I don't know. I need to check the textbook. Okay, let me consult the textbook if it can give me a question like this one. Actually, there are a few. There are a lot. For instance, I've got this one, which is very similar to that one. Just that now, in this particular case, we are using a sec. We're not using ton. And yeah, I can also do this one. But let me do number 13. Number 13 also has a red B. I told you I want these ones with the red red showing. Red showing. You see this red color here. This one. I love such questions. Okay, let me do that one as our party present. But my guy, I mean, I don't know. It's written Moabe. Moabe, please do number 9 on the questions. Okay, or should I write it here? Let me write it. Please do number 9. This goes to everyone, guys. Okay, this one that I just proved here is just a generalization problem. Okay, this is just me generalizing this. Okay, so your problem is this one. This is specific. How you solve it is very important. How you solve it, because it's the exact same question. It's just it, not exactly, but the exact same. So it's given as the integral from 2 to 3, integral from 2 to 3 of dx all over x squared minus 1 to the exponent. Okay, this is number 9 from the text. I don't like such questions. I want these hard. And these hard. So me, the question that I'm doing for you as a department present is number 30. Okay, 30, which has got the red one. Now, the reason why I'm doing the red one, guys, is because if I'm able to make examples with the strong or hard questions, I'm able to open your minds to doing these smaller questions. Okay, it becomes even faster, effective, and you gain confidence because you feel like, okay, we were able to solve such a huge or a humongous question, and then we managed to make it simple, and we managed to drop it down to an extent that we were able to solve it much quicker. Okay, so in this particular case, me as my present to you guys, I just want to do the hard questions as the examples. Okay, such that even when you get to exam and you're given a problem that is harder than that one, you're going to able to get as much marks as you can because you understand the logic behind it. Okay, so the question is, I must integrate the square root of x squared minus 9 all over x cubed. Okay. Oh, wait, guys. Okay, remember on the last question, the solution I got was, I think it was 1 over square root of 2 squared. And the question that I was doing before, what is the solution I got there? Oh, is that one of 5 minutes? Ne? I think so. I think it's that. I think the solution I got there was the square root of x squared minus 7 plus c. Okay. So what's going to happen is, let us check if these solutions do correlate to the solutions. Okay, such that we are confident. Okay, such that we are confident. Okay, I bought this book, guys. Don't think I bought this book. I'm kidding. I'm sorry. It's Bella Devans. It's exercises 7.3. Yeah, exercises 7.3. Okay, so we're doing number 7. Okay, and the other one was number 17. Wow, I started number 17. Wow. Okay, so the solution for number 7, it's actually this one. Do you see the solution for number 7? Number 7 is that one which I was just solving. Just okay, this one. Okay, and then let's look at number 17. Number 17 is that one that I get 5 minutes to go. 7 and 17, they both appear and they correlate exactly to the solutions that I got. Okay, I just want us to be confident, guys. I want to build your confidence in mathematics. Mathematics is nice. Okay, in our next session we'll be doing okay, I'll tell you just. You see, we are doing number 7, which is this question, and then we did number 17, which is this question. Okay, and they've got this red thing. Both of them, they've got this red color. Okay, even number 30. Okay, so we're gonna check our solution just after doing this question. Okay, I want to build your confidence. It's important that I build it. I should make sure that confidence is okay. So we've got this question here. Okay, this one is sec. I knew if maybe I chose something with sign, you were going to say, this one you like sign only, sign only. No, I also like everything. It's mathematics. I don't know why, guys. This time I'm gonna start it in a different way. I know I forget this. That's why I'm starting it. Okay. So we are going to let our x be equals to now this one is our a in this case. So it becomes 3 sec theta. So which means our dx is equals to 3 sec theta tan theta. Okay. Okay. Oh, please, guys, please make sure you send me this solution by tomorrow. It's Saturday. By 8 today. Yeah, by 8 today. Okay. So if this is true, then it tells us that sec of theta is equals to x over 3. Okay. What is that supposed to mean? Okay. Sec is the reciprocal of cos, meaning that our cos is x over r. This becomes our r over x. Okay. This is x. This is r. This is the side that is this is x. Okay. Guys, I'm hoping that now you are getting the idea. Like doing more questions makes you see the pattern that is happening. Okay. Then let's define this. Let's define this. X squared minus 9 is exactly equal to the square root of 3 sec theta squared minus 9. This is equals to the square root of 9 sec squared theta minus 9, which is equal to the square root of 9 sec squared theta minus 1. This is equals to 3 tan theta, because we know that sec squared theta minus 1 equals to tan squared. Okay, but since you've got the square root here, it's just gonna be okay. Now we're gonna do the part that we love the most, one that is x squared minus 9 x cubed. X cubed. This is equals to, okay, guys, do you see? I always forget this. I don't know. Okay, so here we're going to have the integral of 3 tan of theta all over. Now our x is given by the, this becomes 27 sec cubed theta. Okay, and our dx is given by 3 sec theta tan theta. Okay, as you can see, this becomes squared, then this becomes 9 tan squared theta all over 27 sec squared theta. And this becomes 1 over 3, because I know 9 goes 1 time, it goes 3 times here. Okay, and this becomes tan squared theta over sec squared theta. Okay. Oh, I can write this as 1/3 and have sine squared theta cos squared theta multiplied by cos squared theta. Okay. I'm expecting a question. How, 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 how? Okay. But if it's not there, okay. So comes this and that. This would be equals to 1/3. Okay, 1/3. Integral of sine squared theta. Hey, which one is this one? Oh, now this is what happens, guys. Okay, you remember we had this thing of writing sine 2 theta. No, it's not sine, it's cos. Cos 2 theta is 1 minus sine squared. I think let's see. I think there should be a 2. Oh yeah, must. Okay. And then we had this other one. It says that cos 2 theta is equals to cos squared theta. I can't remember this thing very well, guys. I can't remember it. I must go back to the archives. Okay. This thing of trigonometric functions. Okay, let me check on the textbook, but it's gonna take forever. Check the textbook, guys. I don't want to waste time. Okay, but I will remember it. I know I will. Okay. Oh, it's actually it's cos of 2 theta is 1 minus 2 sine squared theta. This is the one. And then this becomes 2 sine squared theta, 1 minus cos 2 theta. Then we divide by 2. Sine squared theta is equals to 1/2 minus 1/2 cos 2. You see now, I'm gonna use this definition here. Okay. So what happens is I'm gonna have 1/3 integral 1/2 minus 1/2 cos 2 theta. Okay. Everything is divided by Okay, guys, my phone switched off and it was very low. Can you please continue with the question which we're doing, the last question? And yeah, I'll confirm your solutions on Ifundi. If needs be that we have to do, no, we need to make sure that we complete these questions and stuff. Okay, and please do that question number 9, and please submit it before 8 o'clock. Okay, please submit it before 8 o'clock. Yeah, for now, due to my phone switching off, and okay, yeah, let me do this. Okay, let me do this.